Dear students, let us start with new chapter, Introduction to Trigonometry. In this chapter, we will discuss the following points: Introduction, trigonometric ratios of angles, trigonometric ratios of some specific angles, trigonometric ratios of complementary angles, and fifth one is trigonometric identities. Students, the topic number 2, 3 and 4 are easier, but the fifth one, that is trigonometric identities, that require maximum practice. So try to solve as many as sums as you can. Now let us start with the introduction. Trigonometry is a word that is derived from two Greek words. One is trigonon and second is metron. Trigonon means triangle and metron means measurement. Therefore, trigonometry that deals with measurement of triangles. Now here you come to know that the trigonometry deals with the measurement of triangles, then definitely a question comes to your mind that what is the purpose of trigonometry? The purpose of trigonometry is that if some sides and angles of a triangle are known, then how to find the remaining sides and angles. This is so simple purpose of trigonometry. Here you see some images on the screen. In this screen you see a pillar, and if you wish to find the height of this pillar, trigonometry will come to your help. In the second image, an aeroplane is flying in the sky, and you have to find the height of that aeroplane from the ground. Definitely trigonometry will help you. You can even find the speed of the aeroplane with the help of trigonometry. The designers of machine tools, they also use trigonometry to design the machine tools. Since ancient times, trigonometry was used in astronomy. This technique was used to measure the distance of nearby stars. In 240 BC, Eratosthenes calculated the radius of the earth using trigonometry and geometry. A group of European astronomers started an experiment in 1997 and calculated the distance between the Venus and the Sun. It was 10 crore 50 lakh kilometer. How astonishing trigonometry is, no? Apart from this, many modern buildings have beautifully curved surfaces where trigonometry is used. Regular flat shapes like squares, pentagons, hexagons can be made out of triangles, and so trigonometry plays an important role in architecture also. Friends, apart from this, trigonometry is used in navigation, electronics, biology, medical imaging, pharmacy, chemistry, materiology, oceanography, music, yes, also in music, computer graphics, different fields of engineering, and practical art of surveying. In so many different fields, trigonometry is used, and therefore it becomes very, very essential to learn the subject trigonometry. Now let us start with trigonometric ratios. In previous classes we have studied about ratios. Suppose 25 is divided by 15. This we write as 5 multiplied by 5 upon 5 multiplied by 3 and here 5 and 5 get cancelled, and that is equal to 5 upon 3. So to write the ratio in the simplest form, we cancel out the common factor from the numerator and the denominator, and whatever we get, that we call it as a ratio in the simplest form. So whenever a ratio we write in the simplest form, we have cancelled out the common factor from the numerator and the denominator. Students, please remember this. Now here, what are trigonometric ratios? Suppose this is a triangle ABC, and this triangle ABC angle B is 90 degrees. Then we know that the side which is opposite to the 90 degree is always called as hypotenuse. And here I denote angle A by theta. And so the side which is opposite to theta is called as the opposite side. And the remaining side AB, which is adjacent to angle theta, of course hypotenuse is also adjacent to angle theta, but since that side we call it as a hypotenuse, only one side, adjacent side, remains, and that adjacent side is called as adjacent side of angle theta. So here we get 3 sides and 3 angles and total 6 parts. And from these 6 parts we get 6 trigonometric ratios. And that trigonometric ratios are sin theta is equal to opposite side upon hypotenuse. Then second one is cos theta. Cos theta is equal to adjacent side upon hypotenuse. And tan theta, that is equal to, it is a ratio of sin theta to cos theta, so sin theta upon cos theta, so which is equal to this ratio divided by this ratio, so hypotenuse and hypotenuse will get cancelled and we will get opposite side upon adjacent side. Now the next one is cosec theta. Cosec theta is equal to reciprocal of sin theta, so it is 1 upon sin theta, which is equal to reciprocal of sin theta will be hypotenuse upon opposite side, so cosec theta, that is equal to hypotenuse upon opposite side. Then the next ratio is sec theta, that is equal to, it is a ratio of reciprocal of cos theta, so reciprocal of cos theta will be hypotenuse upon adjacent side, so it is hypotenuse upon adjacent side. And the last one is cot theta. Cot theta is a reciprocal of tan theta, so reciprocal of tan theta, that is cos theta upon sin theta, and that is equal to adjacent side upon opposite side, so cot theta, that is equal to adjacent side upon opposite side. So here we have got 6 ratios. One is sin theta, that is opposite side upon hypotenuse, cos theta, that is adjacent side upon hypotenuse, tan theta, that is sin theta upon cos theta, and which is equal to opposite side upon adjacent side, cosec theta, is 1 upon sine theta, so it will be hypotenuse upon opposite side, and sec theta is 1 upon cos theta, that is equal to hypotenuse upon adjacent side, and cot theta, that is equal to 1 upon tan theta, so which is equal to adjacent side upon opposite side. Students, sometime we get confused whether cosec theta is a reciprocal of sin theta or it is a reciprocal of cos theta, and that too at the time of examination. If you are confused like this, there is one trick how to remember. Now here cosec theta, that begins with cos, and so it is not a reciprocal of cos theta, but it is a reciprocal of sin theta, and therefore sec theta will be the reciprocal of cosec theta. Now here one more thing, we have seen that tan theta and cot theta are reciprocals of each other, and as we know that the product of the reciprocals is always 1. Suppose there is a number 2 upon 3, its reciprocal will be 3 upon 2, so their product will be 3 will get cancelled, 2 will get cancelled, which is equal to 1, and the product of the reciprocals is always 1, and so tan theta multiplied by cot theta, that is equal to 1. Remember this one. Now we will see some illustrative examples. Given that sin theta is equal to 5 by 13, find the value of cos theta, cosec theta and tan theta. Now here it is given that sin theta is equal to 5 by 13, and we have seen that when the ratio is in its standard form or simplest form, the common factor from the numerator and denominator is cancelled out. So if that common factor is k, then this will be equal to 5k upon 13k, and therefore sin theta, that is equal to, we know that opposite side upon hypotenuse, opposite side upon hypotenuse, and so opposite side will be 5k and hypotenuse will be 13k. So if this angle is theta, then this will be the opposite side, and this opposite side will be 5k and the hypotenuse will be 13k. Now here we have to find cos theta. Cos theta is equal to adjacent upon hypotenuse. We do not know the adjacent side, so first we will have to find the adjacent side, and since triangle ABC is a right angle triangle, right angled at B, then we can apply the Pythagoras theorem to find the side AB. So according by Pythagoras theorem, in triangle ABC, AB square plus BC square is equal to AC square, and AB square that we do not know, so it will be as it is, AB square plus BC square, that is 5k bracket square, which is equal to AC square, that is 13k bracket square. So AB square with plus 25k square, which is equal to 13k bracket square, that is 13 square will be 169k square, and so AB square, that is equal to, take 25 to the 25k square to the other side, we will get 169k square minus 25k square. So AB square is equal to 169 minus 25, that will be 144k square, and therefore AB square, taking square root of both the sides, we will get AB is equal to 12k. Friends, highlight this. AB is equal to 12k. Always try to make your answer paper examiner friendly. If it is examiner friendly, the examiner finds it easier to check. And so the first value you are getting, that is the length of side AB, and therefore it is to be highlighted. So AB is equal to 12k. So this will be equal to 12k. Now you have got all the three sides of the right angle triangle, and so you can find the ratios cos theta, cosec theta and tan theta. So first is cos theta. Cos theta is equal to adjacent side upon hypotenuse. So which is equal to adjacent side is 12k upon hypotenuse is 13k. So k and k will get cancelled and you will get it as 12 upon 13, and so cos theta is equal to 12 by 13. Highlight this also. Then the next is asked as cosec theta. Cosec theta is equal to, we know that cosec theta is a reciprocal of sin theta, and the sin theta is given as 5 by 13, and so its reciprocal will be 13 by 5. So cosec theta, that is 13 by 5. Now the next one is tan theta. Tan theta, which is equal to sin theta upon cos theta, that is opposite side upon adjacent side. So which is equal to opposite side is 5k and adjacent side is 12k. So 12k, which is equal to k will get cancelled and it is 5 by 12, and therefore tan theta is equal to 5 by 12. Highlight this also. Highlight the value of cosec theta also. And when you highlight, you compel the examiner to show what you expect that examiner should see in your answer sheet. So here AB is equal to 12k, first step. Cos theta is equal to 12 by 13, second step. Cosec theta is equal to 13 by 5, third step. And tan theta is equal to 5 by 12, that is the fourth step. Next question is sin B is equal to 1/2 and show that 3 cos of B minus 4 cos cube of B is equal to 0. The figure is that A, this is B and this is C. This angle is angle B, and it is given that sin B is equal to 1 by 2, and we have to find 3 cos B minus 4 cos cube B, and its value is 0. So sin B is equal to 1/2. It means the common factor from numerator and denominator is cancelled out. Let that common factor be k, then the 1 will be k and it will denominator will be 2k. So sin B is equal to k upon 2k, and sin theta is equal to opposite side upon hypotenuse, and therefore opposite side is k and hypotenuse is 2k. Angle B is here, its opposite side is this, and therefore this side will be k and hypotenuse will be 2k. This C is right angle. And now to find the value of cos B, we will require adjacent side, because cos B is equal to adjacent upon hypotenuse, and therefore by applying Pythagoras theorem to triangle ABC we will find BC. So in triangle ABC, we have AC square plus BC square is equal to AB square. This is by Pythagoras theorem. And AC square is K square plus BC square that we do not know, which is equal to AB square, that is 2K bracket square. So it will be K square plus BC square is equal to 4K square. Now take K square to the other side, and so it will be BC square is equal to 4K square minus K square, that is 3 square. So BC square is equal to 3K square. And taking square root of both sides, we get BC is equal to K root 3. So BC will be K root 3. Therefore cos B, that is equal to adjacent side upon hypotenuse, which is equal to K root 3 by 2K. So here K and K will get cancelled and it will be root 3 by 2. So cos B is root 3 by 2. And so we get 3 cos B minus 4 cos cube of B, that is equal to 0. This we have to show. So 3 cos B, 3 into cos B is root 3 by 2. So it will be root 3 by 2 minus 4 into cos cube of B. So it will be root 3 by 2 its cube. So it is 3 into 3 root 3 by 2 minus, this will be 4 into root 3 into root 3 into root 3, that is 3 root 3 upon 2 2s are 4, 4 2s are 8, 4 1s are 4, 4 2s are 8, and so you get 3 root 3 upon 2 minus 3 root 3 upon 2, which is equal to 0, and so that is equal to LHS. That is equal to RHS. So here we have proved that 3 cos B minus 4 cos cube B is equal to 0. The next question is in triangle ABC, right angled at B, AB is equal to 24 centimeter, BC is equal to 7 centimeter. Determine sin A, cos A, sin C and cos C. Here AB is 24 centimeter and BC is 7 centimeter, and so we have to find sin and cos. So it will require the length of hypotenuse. So first we will find the length of hypotenuse by Pythagoras theorem. So in triangle ABC, AB square plus BC square is equal to AC square, and AB square, that is 24 square, plus BC square, that is 7 square, which is equal to AC square. So here 24 square is 576 plus 7 square is 49 is equal to AC square, and 576 and 49, that is equal to 625, which is equal to AC square. Taking square root of both the sides, we get AC is equal to 25 centimeter. And since AC is equal to 25 centimeter, highlight it. So AC, that is hypotenuse, is 25 centimeter. Now we will find sine A. So sine A, that is equal to opposite side upon hypotenuse, and so which is equal to opposite side is 24. Sorry, sine A we have to find, so opposite, so angle is this, and so opposite will be BC, and so it is 7 centimeter, and hypotenuse is 25 centimeter, so it will be 7 by 25. Then we have to find cos A. So cos A, that is adjacent upon hypotenuse, so this is the adjacent side, this is the hypotenuse, so cos A is adjacent side upon hypotenuse, so which is equal to 24 by 25. Then we have to find sin C. Sin C, that is equal to again opposite side upon hypotenuse, but here now angle is changed, so sin C, so its opposite will be 24 and hypotenuse will remain same, so it will be 24 by 25. We have to find cos C also. So cos C adjacent upon hypotenuse, so for C adjacent will be this, and so adjacent side is 7 centimeter and hypotenuse is 25 centimeter, and therefore sin A is 7 by 25, cos A is 24 by 25, sin C is equal to 24 by 25, and cos C is 7 by 25. The next example is given that 15 cot A is equal to 8. Find sin A and sec A. Suppose this is a right angle triangle A, B and C, and this is 90 degree, and we have to find sin A and sec A. It is given that 15 cot A is equal to 8. So this can be written as cot A, which is equal to 8 by 15. Since 8 by 15 is in its simplest form, it means the common factor from the numerator and denominator is cancelled out, and let that common factor be 8k, and so it will be 8k by 15k. Cot A is equal to adjacent upon opposite side, and therefore adjacent side will be 8k and opposite side will be 15k. So adjacent side is AB, so it is 8k, and opposite side is BC, so it will be 15k. Now we will find hypotenuse. Since this is a right angle triangle, we will apply the Pythagoras theorem. So in triangle ABC, AB square plus BC square is equal to AC square. So AB is 8k, its square, plus BC is 15k, bracket square, is equal to AC square. So 8k square, that is 64k square, plus 15, that is 225k square, which is equal to AC square. Therefore AC square is equal to 289k square. So taking square root of both the sides, we get AC is equal to 17k. So here hypotenuse is 17k. So highlight this step, that is AC is equal to 17k. Students, don't forget to highlight the important steps. Now here you have to find sin A. So sin A is equal to opposite side upon hypotenuse. So which is equal to opposite side is 15k and hypotenuse is 17k, so it will be 15k upon 17k will get cancelled, so which is equal to 15 by 17, and so sine A, that is equal to 15 by 17. Highlight this second step. Then next we have to find that is sec A. Sec A, that is equal to hypotenuse upon adjacent side, so which is equal to hypotenuse is 17k and adjacent side is 8k, so it will be 17k by 8k, so k will get cancelled and which is equal to 17 by 8, so sec A is equal to 17 by 8. Highlight this step. So here there are three important steps. First is AC is equal to 17k, second sine A is equal to 15 by 17, and third is sec A is equal to 17 by 8. Students, we will stop here, and in the next session we will see more sum on the same topic. Thank you very much.